Hello guys, welcome back to the channel. Today we are going to discuss about a problem from collision which came in 2025 JEE Advance paper. So this question is from 2025 Advance paper, paper 1, and this is the second question. The question reads like this: in a scattering experiment, a particle of mass 2m collides with another particle of mass m which is initially at rest. So 2m mass is moving but m mass is at rest. It says, assuming the collision to be perfectly elastic, the maximum angular deviation theta of the heavier particle. So how much this 2m mass will deviate? This deviation angle is given by theta. They are asking what is the maximum possible value of this theta. Now we will solve this in a different approach. We will not write the normal equations and then for maxima or minima we used normally do the differentiation part. We won't do it that way. We'll approach in a different way. Let's see that solution now. See here, we have drawn the diagram. This diagram here is in the frame, ground frame. The 2m mass is moving and it is colliding with mass m. Now after collision, this is the direction 2m moving and this is the direction in which m mass is moving. The velocity v1 and v2 I have shown here. This v1 and v2 are the velocity of 2m and m in ground frame after collision. Now the same velocities in center of mass frame I am using in COM frame. Velocity of 2m I am writing as v1c and velocity of m I will be writing as v2c later. Now see here, we are writing velocity of center of mass. We are using m1 v1 plus m2 v2 by m1 plus m2, that formula, and we are getting is 2v by 3. So center of mass is moving at 2v by 3. If we are drawing the same diagram but from center of mass frame now, if we sit at center of mass and observe, then center of mass doesn't move, right? The velocity of center of mass is 0 now in COM frame. But from center of mass, see velocity of 2m, we subtract velocity with respect to ground and minus velocity of center of mass. The velocity of 2m is v by 3 and velocity of m comes to be 2v by 3 in COM frame. So when we sit here and analyze, the velocity of 2m, which is towards center of mass, and velocity of m is also towards center of mass, but their values are v by 3 and 2v by 3 now. So now if we do momentum conservation from here, see in center of mass frame we are doing this 2m into v by 3 which is towards right, m into 2v by 3 which is towards left. This net momentum is 0, right? So in center of mass frame initial momentum comes to be 0, so final momentum must also be 0. The final momentum I have written this way, 2m into v1c. V1c is velocity of 2m after collision, and in COM frame. This is v2c, which is velocity of m mass after collision. So this term gives the total momentum after collision. But this must be 0. So if it is 0, then 2m into v1c and m into v2c, they must be equal in magnitude but opposite in direction. Now we can see it in a different way. See, as center of mass is not moving, I am treating it as a wall. Now let's say 2m collides elastically, it must come back with the same speed. If it goes with v by 3, it should come back with v by 3 again. Elastic collision, right? Similarly, m mass goes with 2v by 3 and it should also come back with 2v by 3, same speed. But what if the wall is not this way? Imagine if the wall is little bit inclined, then what would happen? This 2m will collide elastically, but after collision it will go with same speed v by 3 but in some different direction, right? Similarly, this m mass, it will collide with 2v by 3, speed will remain same but it will deviate in certain other direction. Now here they have not mentioned collision is head on or elastic, sorry, head on or oblique, and definitely it must be oblique because there is some deviation. This deviation after collision is possible only when it is oblique collision, right? So we are drawing this diagram now but in vector format. See, we use this concept velocity or motion of any particle can be given as velocity of the particle in center of mass frame plus velocity of center of mass. This is a concept which is used in center of mass. We will use this concept now. I am writing V1. V1 is velocity of 2m with respect to ground. That is V1. So V1 equals to V1c in center of mass frame velocity plus velocity of center of mass. So velocity of 2m mass with respect to ground equal to velocity of 2m with respect to center of mass plus velocity of center of mass. This is what we are writing now. So after writing this, see from here this Vc vector, it is constant, right? Vc is 2v by 3 towards right. As this mass was moving towards right, the center of mass is also moving towards right. So Vc is a constant vector. But what about V1c? V1c's magnitude will be V by 3. This is what we know already. Why it is? It must be V 2V by 3. Sorry, V by 3 again. We can see ki this relation we have already seen. We are writing kinetic energy conservation equation. See the kinetic energy conservation equation again. Kinetic energy of 2m before collision, kinetic energy of m before collision in center of mass frame. These terms are all constant. So this kinetic energy before collision is a fixed term, constant term. So after collision term also must also be constant because it is elastic collision. But from momentum conservation, we already know that these two velocities are in the ratio of 1 is to 2. So these ratios are 1 is to 2 ratio. So think there are two equations and two unknowns V1c, V2c, and their ratio is also fixed and their squares sum is also fixed. So there cannot be multiple answers to these values. These terms must also have a one specific solution, one unique solution, and these values itself satisfy those equations. So v by 3 and 2v by 3 are the only possible solution to this question. We have already seen that in this wall format analogy, that if it collides elastically, it must go with same speed only. There cannot be any other speed in which it goes. The velocities, the speeds must be same. So this V1c speed is V by 3. This is fixed. But the direction we are not certain. We just know that after collision 2m and m will move in opposite direction in center of mass frame. The center of mass frame, the velocities will be opposite to each other. That's what we know. Now we are taking any random possible direction, but the magnitude remains same, right? So what I am doing here, I am drawing a circle, taking this point as center. Why I am doing this? Now any point which is radial like this can be one possible value of V1c. V1c can be this way, V1c can be this way, V1c can be this way, because only the direction changes, magnitude remains same, which is V by 3. So if this will be V1c and this will be Vc, then the different possible values of V1 can be like this. The starting point of this Vc vector and end point of V1c vector. If we join them vectorially, then we get this V1 vector. Vc is constant, but V1c is variable, right, in direction. That means V1 can also vary in direction like this. In the question they asked, what is the maximum deviation of this V1 vector? Velocity of 2m in ground frame. What is the maximum deviation? Means they are asking us maximum value of phi. Now from this triangle we can easily analyze it. The maximum possible value of phi can only be possible in this case. When this V1 vector, here it is shown as a blue line. This blue line I have drawn tangential to the circle. See, any other line apart from this blue line, any other line will have a smaller phi with the VC vector. It will have smaller phi. See, if I join these two, this angle will be something, right? But if I join here, this phi will be smaller. If I join here, this phi will be even smaller. So phi can only be maximum if this blue line, which is V1 vector, goes tangential to the circle. So if it is tangent and this is the radius direction, so this is 90 degree, it forms a right angle triangle here. So I can say sine phi will be V1c by Vc. V1c is our V by m and Vc is 2V by m. So their ratio will give us sine phi equals to 1 by 2. From here we get phi value to be pi by 6, which is maximum possible value of phi. Now, instead of 2m and m, if we generalize the solution, let's say one mass is m1, the other mass is m2, and m1 is greater than m2, and they collide. The certain same scenario, but instead of 2m, they have given as m1. Instead of m, they have given as m2, and m1 is higher mass, and they are asking what is the maximum deviation of m1. So we can generalize this solution as a sin phi, which is maximum deviation case, will be m smaller mass by m larger mass. The smaller mass by larger mass will be the sin phi value. Here the smaller mass is m and larger mass is 2m. The ratio is 1 by 2. The sin phi becomes 1 by 2. So here the answer is pi by 6, which is 30 degree.